Howdy folks, good to see you guys again. Hope you're staying safe and practicing social distancing here during this extended break. This video is to show you the answers to the Chapter 4 review worksheet. So if you look up here on my board, I've got the first few problems up here already. On problem number 1, they have a picture of a triangle that's similar to what I have up here. And they want you to classify the triangle by both its sides and its angles. Now on the test, make sure that you read the questions. And by the way, there should be an email if you're interested. I am going to have tests, and there's an explanation in the email on how all that's going to work. So if you need a check up on that, check your emails about that. But anyways, on this problem, on the test, it'll specifically say either classify by sides or angles. So make sure you're doing each one separately and you understand the difference. On this first problem, if I start by classifying it by its sides, which many people do right away on this problem when they see the two matching sides right there, then this would be called an isosceles triangle when you classify it by its sides. The other classifications by sides, by the way, are scalene. Scalene is when no sides match, and the equilateral triangle, in which all three sides would match. Again, that's equilateral, not equiangular, which is a classification by angles. Looking at this now and classifying it by its angles, I see in this problem that it's pretty obvious on this one, I think, that this angle here at the top is an obtuse angle, very big angle. You know, it's pretty easy to check with a piece of paper, for example. You can see it's clearly bigger than 90. Okay, but if a triangle contains just one obtuse angle, then that makes it an obtuse triangle. Okay, and again, there you're focusing on the angles. Other possible classifications by angles would be if all three angles are acute, no obtuse angle at all, then that's an acute triangle. Another possibility is if there were a right angle, then it'd be a right triangle. And the last possibility, because there's 4 of these, is if all three angles were the same, then that's what I just mentioned a little bit ago. That's equiangular. Okay, so that covers problem number 1. Now on problems number 2 and 3, you'll notice on the worksheet they do not provide you with any kind of picture to go with this. It's up to you if you want. You don't have to, but if you'd like, you could draw your own little picture, maybe off to the side or on some scrap paper somewhere. Like down here at the bottom here, I'm going to go ahead and make a triangle and label it ADC, like it has here in the problem. Okay, now, on problem number 2, they want to know angle A is opposite of what side? Well, here's angle A. And in a triangle, keep in mind, since there's only 3 sides and only 3 angles, that opposite of an angle is not another angle. You know, how would you decide between D and C who would be considered opposite? Instead, opposite of an angle is a side. And you can see across from angle A is the side DC. You see it right there. See it? DC. Okay, if I start over with another picture of that triangle again, ADC, on problem number 3, this time, instead of starting out with an angle and naming the opposite side, it starts out with a side and wants you to name the opposite angle. So side DA, which would be that side right there, they want to know what is opposite, what angle is opposite of that. Again, in a triangle, there's only 3 sides, so you can't consider any of these sides to be opposite of that one. Instead, opposite of this side is this angle. Angle C down here. Okay, so angle C is our answer for problem number 3. So if it helps you draw a little picture on those types of problems, You know, doesn't hurt to do that if it helps you see it better. All right. Flip this over. Okay, problem number 4. That gets us up to. On problem number 4, they've got a picture of a triangle, and on our triangle, notice the exterior angle they created by extending that side out further. And that exterior angle is given in the problem as being 142 degrees. They tell you this angle down here is x minus 3. This one up here is 4x plus 10. And this angle in here, they just have it labeled as y. And they want you to find both x and y. Okay? Now, if the y wasn't involved in the problem, if it just looked like this, to find the x here, what you could do is, we had a theorem, if you remember correctly, the exterior angle theorem, that said that this angle outside of here is going to be equal to both of these two remote interior angles. You know, if you remember right, those were called remote interior angles. They're the ones that are inside the triangle yet furthest away from this exterior angle out here. It turns out then that these two, when you add them up, will equal this exterior angle out here. So you could simply, for your algebra, say that 4x plus 10 plus the other angle x minus 3, those two remote interior angles, when added together, will equal the exterior, will equal 142. Okay, so if I do my algebra over here, I've got a sheriff deputy situation. I'm going to go ahead and combine those to get 5x. Same with the 10 and the minus 3. They combine to give me a positive 7. And that equals 142. Subtract 7 from both sides. And then we can finally divide by the 5 at the end here. Let's see, this leaves you with 135. Divide by 5. And we're going to find that, let's see, 35, 7. X equals 27 in this case. Okay, so that's how you could find your x. Although you could have found it another way. Let me show you. It would involve finding the y though first. Remember, the y up here is right beside that exterior angle, and those two are a linear pair. So we know then that y plus the 142 equals 180. Or, in other words, if we just subtract 142 from 180, we'll have our value of y here. It comes out to 38 for the value of y. Now, going back to this problem over here, finding x, if you knew this was 38, you could say now that all three of these angles would add up to 180 as well. Okay, so, which makes sense. I mean, look, 42 plus the y was going to equal 180. So the 42 must be the equivalent of the other two angles over here, because all three angles in a triangle add up to 180. And that y is involved again. All right, so anyways, that's how you find x and y on problem number 4. Okay, let's see if I'm going to go ahead and erase this. Okay, on problem number 5, we've got a picture of a triangle, and it turns out it's not just any triangle. In the picture, they have marked that these two angles are congruent. Okay, and if you remember, one of our last sections of this chapter talked about isosceles triangles. And when these two base angles match, then we learned that in one of our theorems, I believe it was theorem 4.7. It's either one of the two, 4.6 or 4.7. But I think it was theorem 4.7 that said that opposite of this angle and opposite of this angle then are two sides that will have to be congruent. If the angles match, so do the opposite sides. Okay, so Just so happens in this picture too that they gave you those two sides as being 9x minus 4 and 6x plus 5. So of course we're going to now say those two are equal to each other. So I'm going to say 9x minus 4 equals 6x plus 5 and solve from here. I got a sheriff bandit situation where they're on opposite sides of each other. So I'm going to get rid of the weaker one of the two. And remember, whatever you do to one side, you got to do to the other. So now I'm left with 3x, and I bring the rest of this down. Minus 4 equals 5. Okay, I want to add and subtract as long as I can, so at this point I'm going to add a 4 to both sides, so that now the 3x is by itself, and now I have 9 here, and divide by 3. So we find that x is 3 on that problem. Okay, so watch out for any problems where if the angles match, then that means the opposite sides do. And that works both ways, though. Maybe they'll give you two sides that match, and then across from them, these two angles you would then have to say are equal. So whatever values they give you there, you have to adjust accordingly. All right, that gets us up to problem number 6. And in problem number 6, they've got a picture of a couple of triangles that look like this. Okay, and then there's a line going across here. There's my two triangles. This is labeled as A, D, C, and B. They indicate right angles here and here. They also indicate this angle matches that angle. This angle matches that angle. This side matches this side. That side matches that side. Okay, and they have a congruence statement about the triangles that's being made. They've already written the first part. They say triangle ACD is congruent to. And you're supposed to fill in the blank here with the other triangle. Okay, now when you do a problem like this, order of the letters is very important here. Whatever first letter is written here is going to need to match up with the first letter of our next triangle as well. And I think one of the best ways to make sure that you do this correctly is look at your picture over here and make sure that you pair up the corresponding parts. Make sure you can see that here. Need to tilt this down just a little bit further. Okay, so it's kind of off the picture a little bit there, but down here is angle C. Okay, but angle A on this triangle on the left, see that small angle there? It's corresponding with angle C on this triangle. So I'm going to pair my A up with my C. Okay, and then I do the same with my next letter. My next letter was C. So on that first triangle, ACD, angle C is that double marking here. That's going to match this double marking on this triangle, which is the A on that one. So A would be my next letter that's supposed to correspond with this C. Okay, and then finally, the D. The D is the right angle. Over here it's B. So B is supposed to match up with D. Okay, again, the order of those letters is important. It'll be marked wrong if you don't get them in the correct order. So if this one starts out ACD, this one has to be CAB. And again, the angles give it away. A was single, C was a double, D was the right angle. So we're going to single, double, right. When we name this one, single, double, right would be CAB. Okay? So make sure you keep that order in when you write those. All right, that gets us up to problem number 7. Okay, on problem number 7, they make a statement right at the beginning that triangles JKL and ABC are congruent. Okay, what I just mentioned a little bit ago comes into play here then. Don't forget that it's very important, the order of the letters. Okay, because then they go on to say that not only are the two triangles congruent, but then they tell you the measure of angle J is 36 degrees. The measure of angle B is 64 degrees. And the measure of angle C is 3x plus 52. And they want us to find x on this. All right, so sometimes it might help to make a picture. You know, they aren't going to provide one for you here. But if you were to make your own picture, try to reflect what they said up here. Okay, so if I call this, for example, JKL. See how I went up and over the triangle? JKL in that order. Well, then over here I gotta do the same thing. I want to make a matching triangle over here, ABC, so that all my corresponding angles match. You know, J matches A, and K matches B, and L matches C. And then if I label them, you know, with what was given, J is 36 degrees over here. B is 64 degrees. And angle C here, this one is the 3x plus 52. Okay, now when I look at this too, I notice then that none of the corresponding angles are here. You know, I have this angle but not its corresponding angle here. I have that angle but not its corresponding angle here. I have that angle but not its corresponding angle there. Instead, what I'm going to do then is I'm going to take this 36, since I know it's supposed to match angle A, I'm just going to transfer it over here. And now I've got all three angles involved on that triangle. And we know that all three angles of any triangle add up to, you guessed it, 180. So off to the side here, we're going to do this equation. We're going to say that the 3x plus 52 plus these other two, plus the, well, here, let's do it down here where I got more space. Plus these other two, the 64 and the 36. Okay, all three of those have to add up to 180. All right, so then it's just some algebra from here on out. Again, all of these constant values, you can treat them like a sheriff and a deputy. They're on the same side. So we're going to combine all those. Let's see, what do we get for that? 110, 140, 150, 152. Okay, and then I'm going to try to isolate the x here, so I'm subtracting my 152 over to the other side. So I've got 3x now equals 28. Okay, and then finally we're going to divide by the 3. Here, I'll put it up over here now. 3x equals 28. We're dividing by the 3. And on this one, you don't get a nice whole number. You get 9 1/3. 9.3 repeating. Okay, but that's one that involves angles. Okay, on this same review worksheet, though, the very next problem, problem number 8, now is going to be a couple of congruent triangles, but this time, instead of it involving the angles, this time it's going to involve the side lengths. It's problem number 8 that I'm talking about here. And on that problem, again, they start out with a statement that a couple of triangles are congruent. And again, that statement is very important, though. It kind of unlocks the whole problem, because if they say ABC equals DEF, the A corresponds with the D, the B corresponds with the E, the C corresponds with the F. Okay, but then they also go on this one to give you some side lengths. They tell you that DE is equal to 10, EF is equal to 13, DF is equal to 16, and finally side AC is equal to 4x minus 8. And again, they want you to find x. All right, so you could draw a picture. Again, you don't have to. If you look at the corresponding parts here, you could actually figure it out without a picture, but I always like to have a visual of it, so I'll go ahead and draw a picture to go with it here. So I've got a couple of triangles again that are supposed to be congruent here. And again, I want to letter them the same way. So if I go up and over ABC on this one, and this is just going to be a simple translation to the new spot, then this one would be DEF, again going up and over. So that all my corresponding vertices match up there again. DE is 10, EF 13, DF 16, AC is the 4x minus 8. Okay, with the picture now, I hope it's obvious. Do you see how the bottom sides here are supposed to correspond with each other? You know, the A and C here match the D and F there. A, C, D, F. So I'm just going to, and the rest of this is useless information. The 10, the 13, they were just there to throw you off. They wanted to see if you could figure out which side corresponds. In this case, the DF side that was 16 is going to match the 4x minus 8. So there's our algebra equation. 4x minus 8 equals 16. We're going to add 8 to both sides. That gets us up to 4x equals 24. And then, of course, we're going to take that and divide it by 4 to get x. X is 6 on this problem. Okay? So if it involves sides, congruent triangles, and sides are involved, you're going to have to find a matching pair of sides here. You know, there's no trick to doing the adding up to 180 part like we did on the angles, because that's only true about angles, not sides. All right, so that gets us through page 1. Okay, on Google Classroom, by the way, there are also PDFs I'm sorry, pictures on there of each of the pages, the answer key, so you can follow along on there too if you'd like. All right, but that gets us up to page number 2, which starts with problem number 9 then. Okay, and on these problems, they want to know which theorem or postulate, if any, can you use to prove the triangle's congruent. Okay, when they say that, which theorem or postulate, okay, I've been calling those our shortcuts to prove triangles congruent. Remember, we have an extensive list of these. I'm going to put them off in the corner here. There's SSS is one of our choices. There's SAS, ASA, AAS. Remember, those are different. Okay. And the last one was HL. There's a total of 5 ways. And if you cannot prove the triangle is congruent at all, you know, you could just put not possible. Okay, that is a 6th option, you know, on these problems. So when we look at problem number 9, okay, the picture for problem number 9 looks something like this. And they indicate this angle congruent to this one, that side congruent to that one. Okay, so when I look at this problem, I see there's only 2 pairs of congruent parts. Remember, all of our shortcuts require not 2, but 3 pairs of parts. Even HL, if you remember right, HL only works for right triangles, but it does assume then that you have a right angle already. So there's no A written here for the right angle. They don't call it HLA or something like that. The A is understood, the right angle is already understood, and then of course the hypotenuse and a leg are also necessary. But when I look at this one, I see there's only 2 parts congruent so far, so I'm looking to see if there's anything else I might be able to mark congruent. Okay, in our 10 Commandments, this also is stated in there, you should always keep an eye out for 2 things when we're dealing with these types of problems. You want to see if the triangles share a side. In this problem, they do not. And the other thing you want to look out for is vertical angles. In this case, we do have vertical angles. Okay, remember those problems we did earlier where we were trying to figure out what do you still need to prove the triangle is congruent? And that would be one of those things here. We need that yet. That gives us a 3rd pair of parts. So now I should be able to figure out a shortcut to use here. Assuming it fits in one of those spots like SSS, SAS, ASA, AAS, or HL. Well, when I look at this problem, one of the things I like to do is I like to kind of cover up one of the problems, one of the triangles. Okay, and when you look at it, then you can isolate down what parts you have. Here I've got 2 angles and a side. Okay, so if it's 2 angles and a side, I already know it's one of these 2 problems. One of those 2 shortcuts. Because that requires 2 sides and an angle. That requires all 3 sides. HL is 2 sides and an angle. So it's got to be one of these 2. It's either ASA or AAS. The only difference between the 2 of those is that the side here has to be in between or included. And here the side is not included, not in between. So when I look at my problem, here's the 2 angles of one of the triangles. The included side would be the one that joins them. It'd be right there in between there. But this is not the one in between. So this one is one of our newer shortcuts, the AAS on that one. Okay, if you look at problem number 10, this one has a picture of a couple of triangles that look something like this. And they indicate these 2 angles match. These 2 sides match. Okay, like our last problem, I only see 2 pairs of parts congruent. So I know there's a good chance that there's something else congruent. Here it was vertical angles. On this one, do you see that they share that side down the middle? Right there. Okay, and if they share that side, it has to be congruent by the reflexive property. Okay, so now I've got enough, I should have enough to prove it again using one of our shortcuts over here. This time, when I focus on one triangle at a time, I see that I have 2 sides and an angle. 2 sides and an angle. Okay, 2 sides and an angle is more than likely going to be either SAS or possibly HL. Remember, HL is the one that spells donkey in the end, but it only works for right triangles using the right angle. Okay, when I look at this problem though, I noticed that on each triangle it does spell donkey because these 2 sides, the included angle would be the angle that's right here forming those 2. If I erase that, you see it? Those 2 sides make that angle. So that's the included angle back here. Okay, that is not the included angle. Okay? And remember, you can't spell donkey. If I got 2 sides and I don't have the included angle, can't do that. The only time you can is under HL, but I have no indication that those are right angles. Don't assume that those are right angles. So this one is not possible. We put down not possible. It's not possible to prove the triangle is congruent. They could be. We just can't prove it. Okay, remember you can't spell donkey except for HL and you call it HL. Don't call it donkey. Alright, let's look at problem number 11. On problem number 11, they indicate a right angle here and these 2 sides match. Okay, of course, if that's a right angle, then I can mark the other right angle right here beside it. And again, that's only 2 pairs of parts. All our shortcuts require 3. So there's probably something else congruent. Just like on this problem, they share a side down the middle. So I know that side has to be congruent. But the difference this time, instead of spelling donkey, okay, this one actually does not spell donkey, because you've got two sides and the angle right in between. Remember, if I ignore the third side, see the two sides form that angle, so that's definitely the angle in between. So if I have two sides and the angle in between, that's SAS. Okay, don't forget we do have a shortcut HL that only works for right triangles, but don't assume just because these are right triangles that it's HL. Okay, if it was HL, by the way, just for your information, you would have to have a hypotenuse and a leg besides the right angle. So these are both legs. See that? That's a leg, that's a leg. So you need to have something like this. Instead of having that, you would have to have this hypotenuse. Now, if that was the case, now this would be HL. Okay, and notice it does spell donkey. ASS, okay? But don't call it that, call it HL. And it only works for right triangles. Okay, but you have to have the hypotenuse across from the right angle and a leg. Okay, but that, on the review sheet, it was SAS. I'm just showing you this in case you want to know about HL yet. All right. That gets us up to problem number 12, which was a proof. So let me erase my board here. Okay, and keep in mind, I'm not out to get you. The proofs aren't going to be the most difficult thing I could come up with or something, you know. I'm just going to give you a basic proof, kind of like this problem number 12. And in this problem number 12, we are given that angle 1 is congruent to angle 4, and angle 2 is congruent to angle 3. Okay, the picture kind of looks like this. You got angles 1, 2, 3, and 4. And the vertices are labeled A, M, E, and O. Okay, we're trying to prove that side AM is congruent to side AO. Okay, you know that the first thing we do on a proof is just copy the given. So we're just going to copy down all of this. 1 is congruent to 4, 2 is congruent to 3, and say that it is given. Okay, and one of the things I always recommend you do is mark any congruent parts in your drawing as well. So 1 is congruent to 4, 2 is congruent to 3. Okay, marking the picture, by the way, is going to help you see in the end what shortcut we might use to prove the triangle is congruent. You know, like the SSS, SAS, ASA, AAS, HL, all that good stuff. Now, most of the time, the givens are going to lead to something. Here, they're kind of dead ends. You know, they already led to congruent parts. Okay, but don't forget, you know, if a given says that the lines are perpendicular, that's going to lead to some right angles. And right angles are always congruent then. If it said that it bisected a side, okay, that's going to cut that side into 2 equal halves, so you'd have 2 sides that would match in that case. And that would lead to a step using the definition of a bisector. You could even, they might even state it a different way and say that a point's right in the middle, a midpoint. Midpoints will split it up into 2 equal halves. You know, so again, that would lead to a step where you would say that 2 segments are congruent using the definition of midpoint. So, you know, there's different things I could give you here that would lead to other steps. But in this case, none of these givens lead to anything. I look at my picture, though, I notice that they are sharing a side. Remember, in your 10 Commandments, that's something that I said keep an eye out for, is vertical angles, and if the triangles share a side. So if they share this side, it has to be congruent between the 2 triangles, so I'm going to state that. that side AE is congruent to itself. Remember, as we were first learning proofs, anytime that you said anything was equal to itself, you were using the reflexive property. That's the property that, remember, you look in the mirror, you see your reflection. You know, they're identical. Okay, now, I marked it in my drawing as well, and now I can see in my drawing, since I have it all marked up, that I have enough to prove the triangle is congruent because all of my shortcuts require 3 parts. And that's what I have here for each triangle. Okay, so I should be ready now to state that the triangles are congruent. So I'm going to say that the top triangle AME is congruent to the bottom triangle, which, if that one's called AME and this is a reflection I see, it'd be AOE. Okay, and when I look at my picture, that's what gives away which shortcut I'm going to be using to prove the triangle is congruent. You know, if you focus on one triangle at a time, I've got 2 angles and a side over here that's not included. See how the included side would be the one that joins the 2 angles right there? That's not the included side. So it's AAS. Okay, please call it AAS and not SAA. Okay? But anyways, that's the shortcut that proves the triangle is congruent. And once the triangles are congruent, then all of their parts are. I can now get to my proof statement here. It's my last statement. I'm going to say that AM and AO, those 2 sides, have to be congruent because they correspond. Okay, and they're one of the few parts left that I haven't already proved congruent. But once the triangles are congruent, all of their parts are. So we're using CP, CTC, corresponding parts of congruent triangles. That's the key here. You have to have congruent triangles are congruent. Okay, if you've already proved the triangle is congruent in the previous step, that's when you can use CP, CTC to prove our parts congruent. Okay, that CP, CTC not only works for sides, it works for angles, as long as they are corresponding ones. So we could have just as easily proved that this angle A is congruent to this other angle A down below it, using CP-CTC as well. Or you could have shown that ME is congruent to OE, you know, any parts that are left that we didn't already prove using the shortcut. Okay? So that's how you do the proof on problem number 12. Okay, the last remaining problems here are some transformations. Okay, so I'm going to move over here. I've got a little setup here. Okay. I think you can see this, I hope. Okay, on problem number 13, this is the triangle they start out with, and they ask you to do a translation on this one. Okay, translations are pretty easy. All you have to do is follow what it says. On this one, it wanted us to go 2 units to the left and 4 units up. So just take each vertex and do like they said. Go 2 to the left, 1, 2, and 4 up. 1, 2, 3, 4. There would be the new T or T prime on this one. Okay, and then S, same thing. 2 to the left, 1, 2, 4 up. 1, 2, 3, 4. There's the new S or S prime. And U. U would go 1, 2 to the left, 1, 2, 3, 4 up. So there's the new U or U prime. Okay, and then in the end, you just connect this back together to make the triangle. And there you have it, the new triangle T prime, U prime, S prime, after going to the left and 4 up. Okay, so transformations, those are pretty easy. Okay, on problem number 14. Okay, this is the one that tends to give people trouble, is the rotations. Okay, on a rotation, first of all, pay attention to which way you're going. One of the most common mistakes that people make, they rotate clockwise when they should have went counterclockwise, or vice versa. Okay, on number 14, they want us to turn 90 degrees clockwise. Okay, so we're going to be going in the direction of a clock. Okay, the same direction that a clock goes in. Okay, so clockwise on this one would be if I'm going to the right, like that, rotating to the right. Okay, so there's what the answer should look like in the end. Okay, so I'm just going to steal my coordinates, my answer from that right now. I'm just going to jot those down. You know, U stays here at 0, 0. Whoops, let me write that in green. Okay, U stays at 0, 0, so there's where our U prime is going to be. T, or T prime, is now going to be located at 3, positive 2. Okay, and the new S, or S prime, is going to be located now at positive 1, positive 4. Okay, once I've jotted those coordinates down, now I can take my picture, rotate it back to its original orientation. Okay, and now I can plot those points. You know, 0, 0 is right there. So not only is that U, it's now U prime as well. 3, 2 is where the new T goes. 3, 2, right there would be T prime. And the new S prime goes at 1, 4. 1, 4 is right there. So there's my S prime. Oops, prime. Okay, connect those back together to make the triangle. Okay, and there's where the new triangle ends up being, the image of it, after rotating that 90 degrees in the clockwise direction. Okay, so again, just turn your paper like that to do the rotation itself, and then turn it back and plot those points after you had copied them down. Okay, then on problem number 15, now they want us to do a reflection. So the original problem on 15 starts out with a quadrilateral. There's a point L located right here. There's a K that's right here. There's a J that is right here. And there's a point I that's right there. So here's the original quadrilateral. Okay, they ask us to reflect this across the x-axis. Okay, always pay attention to what you're reflecting across. Okay, that's one of the most common mistakes on these reflection problems. They might flip side to side when they should have flipped up and down, or vice versa. Okay, in this case, if we're reflecting across the x-axis, okay, then that means I'm reflecting across this. That's the x-axis, right? Okay, so I'm flipping side to side on this one, not up down. Okay, so we just take individual points, corners here, vertices, and we go back to the line of reflection perpendicular. So you're just going to go straight back to this line, counting. I count 1, 2 units. So 1, 2 units on this side, right there, would be my J prime. Oops, I just realized I made a mistake. That's the y-axis. See, even I mess these up occasionally. So I'm flipping the wrong way. It's not side to side. Draw that back back in there. Should be flipping across the x-axis. Silly. This one right here is the x-axis. So we are flipping up and down here. Okay, so let's try that again. Okay, now see how L is just 1 unit above. So 1 unit below right here would be the L prime. K is 1, 2, 3. So 1, 2, 3 below is the new K prime. J is 1, 2, 3 above. So 1, 2, 3 below is the new J prime. And I is 1, 2 above. So 1, 2 below is the new I or I prime. Connect those back together. And there's the reflection of it. You can see they look like a mirror image of each other. Okay, so that's how you do a reflection, like on problem number 15. Okay, then on number 16, it's another reflection. This time, like I was just ahead of my time, see? On this time, they want to do a reflection across the y-axis. Okay? So this time we will be reflecting across this, the y-axis. But the original figure is another quadrilateral. It's got a point right here that's labeled as S. Point R is at 1, 4. So there's R. Point P is at 2, 1. So that's point P. And point Q, I think that's supposed to be. Looks like an O though. Is at 3, 4. So it's right there. Okay, so our original figure is this quadrilateral. Okay, if we're reflecting over the y-axis this time, we're going side to side. Okay, so we just take each vertex, like R here is only 1 unit away, so 1 unit away over here is now R prime. Q is 1, 2, 3, so 1, 2, 3 on this side is the new Q or Q prime. P is 1, 2 units away, so 1, 2 units away over here would be the new P or P prime. And S was 1 unit on the left. Now it's going to be 1 unit on the right over here. Okay, so if I rejoin those back together, you'll see it. There's the quadrilateral again. And they're exact mirror images of each other again. See how that one kind of slants, down and to the left, and this one's down and to the right. It's just a mirror image. It's been flipped over. Okay, so there you have it. That's problem 16, the last problem on the review packet. Okay, if you could do these problems, you should be prepared and ready for your Chapter 4 test, which would be your next thing that you'll have to complete on Google Classroom. Okay, again, like I said earlier, stay safe and practice social distancing. Okay, I'll catch you guys later. See ya.